Hello, my name is Jacob Winkler, and I will be doing my BMED 213 reflection on 3D printing synthetic organs. 3D organ printing is an engineering design concept that solves a bioengineering problem. Organ failure is a significant problem in the medical industry that affects hundreds of thousands of lives. 3D printing synthetic organ replacements is an exciting new approach to solving this complex issue. The biological problem that 3D printed organs would solve is organ failure. The term organ failure is extremely broad because it refers to a failure of an essential system in the body. Such organs include the heart, lungs, kidneys, and others. There are multiple causes of organ failure ranging from trauma to infection. Additionally, multiple organ failure, or multiple organ dysfunction syndrome, or MODS, refers to the dysfunction of more than one of these systems and is the leading cause of death in contemporary intensive care units. Obviously, organ failure has a large biological aspect. The organs that fail are literally critical to supporting life. Often, to treat any form of organ failure, the dysfunctional organ must simply be replaced. Replacement organs come from organ donors, and the patient undergoes an organ transplant to replace their dysfunctional organ with a healthy one from the organ donor. However, there is a major flaw with this system. As illustrated by the graph below, the problem lies in the availability of replacement organs compared to demand. In 2015, the list of patients awaiting a donation was more than 122,000 names long. This resulted in patients who needed an organ transplant having to wait months or even years for an available replacement organ, many of which died before they were eligible for a transplant. Furthermore, even if patients do obtain an organ from the donor list, there is a significant risk of their bodies just rejecting the transplanted organ. 3D bioprinting could potentially solve both the availability issue and the rejection issue in the current organ transplant system. As a personal side note, 3D printing technology is one of my interests as a mechanical engineer. In fact, I ran many 3D print jobs for senior engineers at one of my past internships. The idea to 3D print synthetic organs truly fascinates me, and it seems like both a really cool and really useful engineering application that could help a lot of people. 3D organ printing can best be described as an engineering solution to a biological problem. To address demands for organs needed in organ transplants, researchers are looking into the creation of synthetic organs that can be rapidly created and have a reduced likelihood of rejection. One methodology to achieve this goal is through 3D printing organs. Also known as 3D bioprinting, 3D organ printing is an additive manufacturing process where biomaterials such as cells and growth factors are combined to create tissue-like structures that imitate natural tissues. The process operates in similar fashion to most conventional 3D printers, but we substitute filament for bioink. The key engineering innovation that allows for 3D organ printing to even remotely be possible is bioink. Bioink is normally comprised of cells proliferated throughout a biopolymer gel. The bioink is then extruded into the shape of the desired organ in the 3D bioprinters. The key aspect of bioinks is that they are entirely biocompatible. This aspect, however, is the current primary limitation of bioprinting. Although synthetic materials provide a good mechanical strength and moldability into the desired shape of the organ, there is a very limited supply of these biocompatible bioinks that can be used. Another notable limitation comes from a technological perspective. Before bioprinting can be commercially feasible, improvements must be made in speed and resolution of 3D printers. Resolution improvements are important for controlling the microstructure of the actual synthetic organ, and printing speed improvements are needed to meet the large-scale demand for organs. As bioprinting technology continues to advance, it could have a very widespread positive impact. On the economic side, current organ transplants are expensive. The typical kidney transplant costs an average of $330,000 according to the National Foundation for Transplants. This cost could drastically be reduced if sourcing for organs becomes much easier through 3D bioprinting. On the sustainability side, 3D printing organs has the potential to become a far more reliable alternative to the organ transplant list. Even if it doesn't replace organ transplants completely, An alternative source for organs would greatly reduce the current dependence on organ donors, resulting in a far more sustainable future in terms of treating organ failure. Lastly, and most importantly, if bioprinting becomes widespread, it could improve the lives of thousands of people who otherwise may not be able to receive organ transplants. And finally, here are the links to all of the references that made this presentation possible. They are all linked in the video description. Thanks for watching.